Gather the necessary materials for the cloud in a jar experiment. These materials include a clear glass jar to serve as the container. Water is needed to create the water vapor for cloud formation. Shaving cream will simulate a cloud layer within the jar. Blue food coloring and a spoon or dropper are required to visualize the rain. A clear glass jar is essential for this experiment. The transparency of the jar allows for easy observation. Visual clarity is important for monitoring changes inside the jar. Ensure the jar is clean and free of contaminants. Proper preparation of the jar is crucial for accurate results. A jar is required as the primary container. Begin filling the jar with water. Continue until the jar is about 3/4 full. Ensure sufficient space remains at the top of the jar. This empty space is essential for subsequent steps or contents. The water contained in the jar serves as a representation of the air present in the sky. This representation is designed to illustrate the concept of moisture being held within the air. Just as the jar holds water, the air holds moisture in the form of water vapor. This analogy helps visualize how the atmosphere retains water. Understanding this concept is crucial for comprehending weather patterns and humidity. Shaving cream is introduced as a visual representation of a cloud in an experiment. The shaving cream's texture and appearance serve as an analogy for cloud formation. It will be used to demonstrate cloud behavior and properties in a simplified manner. The experiment aims to illustrate cloud-related concepts using a tangible model. This method provides a clear and accessible way to understand complex atmospheric phenomena. A simple experiment can simulate cloud formation using readily available materials. The experiment requires a clear jar filled with water. Shaving cream is then sprayed on top of the water surface. The shaving cream creates a fluffy layer that mimics a cloud. This cloud will be used to demonstrate how clouds hold and release moisture. Food coloring can be added to the cloud to simulate rainfall. The shaving cream layer is used to simulate cloud formation. This analogy helps visualize atmospheric processes. The shaving cream represents a cloud in the atmosphere. It provides a tangible model for understanding cloud behavior. This demonstration simplifies the complex concept of cloud formation. Blue food coloring is prepared to simulate water droplets. The blue color will visually represent water in the cloud model. This allows for a clear demonstration of water droplet formation. The colored solution will be used to illustrate cloud behavior. Begin the rain simulation setup indoors. Create a cloud using shaving cream as the base. Use a spoon or dropper to apply food coloring. Slowly drop the food coloring onto the shaving cream cloud. The upcoming demonstration involves adding food coloring to shaving cream. Viewers should pay close attention to the interaction between the food coloring and the shaving cream. Observe how the food coloring disperses or mixes within the shaving cream structure. Note any changes in color, texture, or overall appearance. Careful observation is key to understanding the principles at play. The experiment simulates rain falling from a cloud using common household materials. Shaving cream is used to represent the cloud layer. Food coloring acts as the rain, slowly seeping through the shaving cream. The food coloring's descent creates a visually appealing effect. This demonstration visually represents density and gravity principles. The process highlights how heavier particles descend through less dense mediums. The shaving cream cloud experiment demonstrates the concept of saturation. The shaving cream represents a cloud in the atmosphere. The food coloring simulates water accumulating in the cloud. As more food coloring is added, the shaving cream becomes increasingly saturated. This mirrors how real clouds become saturated with water vapor. Eventually, a saturated cloud releases its water as precipitation. The phenomenon of color falling like rain is being depicted. This effect is caused by the cloud being excessively heavy. The heaviness is analogous to real clouds saturated with water. When real clouds become too full of water, they release it as rain. Similarly, the heavy cloud releases color in a rain-like manner. This visual representation helps understand the concept of saturation and release. Real-world clouds behave similarly to the cloud in the experiment. Clouds continuously accumulate water vapor from the atmosphere. This accumulation increases the water content within the cloud. Eventually, a cloud reaches its maximum water holding capacity. When this capacity is exceeded, the cloud releases the excess water as precipitation. Clouds can only hold a finite amount of water. This water holding capacity is influenced by factors like air temperature and atmospheric pressure. As water vapor condenses and accumulates within a cloud, it approaches its maximum saturation point. Once the cloud reaches its water capacity limit, The excess water is released as precipitation. Clouds are formed through the condensation of water vapor in the atmosphere. As more water vapor condenses, clouds accumulate increasing amounts of water. Eventually, clouds reach a saturation point where they can no longer hold the water. When this capacity is exceeded, the water falls back to Earth as rain. Precipitation occurs when water droplets in clouds increase in size. These droplets collide and coalesce, forming larger, heavier drops. As the droplets grow, they become too heavy to remain suspended in the air. Gravity pulls these heavy water droplets down to the Earth's surface as rain. Science provides the tools to simulate natural phenomena. These simulations are often achieved through controlled experiments. Experiments allow for observation and analysis of complex processes. The ability to replicate nature is a testament to scientific understanding. Through simulation, deeper insights into the natural world are gained. Science is an amazing field due to its power of simulation and discovery. The experiment's initial step involved setting up the necessary equipment and materials. Next, specific procedures were followed to conduct the core experimental process. Throughout the experiment, data was meticulously collected and recorded for analysis. After the experimental phase, the collected data was analyzed to identify key trends and patterns. Finally, the results were interpreted to draw conclusions and validate or refute the initial hypothesis. This segment provides a clear list of materials required for the experiment. The list is designed for easy replication of the experiment by viewers. Each item will be visually presented for quick identification. Quantities of each material will be clearly specified. Alternative materials will be suggested where applicable. Safety precautions related to the materials will also be highlighted. Atmospheric moisture is a key component in cloud formation. Water vapor in the air needs a surface to condense upon. Microscopic particles in the air serve as condensation nuclei. Moisture condenses around these particles, forming tiny water droplets. These droplets, when numerous enough, become visible as clouds. Cloud droplets collide within a cloud. Upon collision, droplets can merge, a process called coalescence. Coalescence increases the droplet's size and mass. When droplets become heavy enough, gravity pulls them down as rain. Convection currents initiate when warm, moist air near the Earth's surface is heated. This heated air becomes less dense and begins to rise, a process known as uplift. As the moist air rises, it cools and expands, leading to condensation of water vapor. The condensation process forms clouds, and continued uplift can result in precipitation. Experiment variations can enhance understanding and engagement. Varying food coloring colors introduces visual diversity. Different colors can highlight mixing and diffusion processes. Adjusting the amount of shaving cream affects the reaction rate. These adjustments provide different observational outcomes. This experiment serves as a practical demonstration of the scientific method. The scientific method is a systematic approach to understanding the natural world. It involves a series of steps, beginning with careful observation of a phenomenon. Based on observations, a hypothesis is formulated as a testable explanation. Experimentation is then conducted to test the hypothesis and draw conclusions.